A1A plus 0. Okay? The distance is 0. And the last, dot 3. U3 is A0 plus 0 plus A2B. OK， 这东西看到没？我们带入这个方程式。And then next, what are we going to do next? We want to solve for the variable A1, A0, and A2. How to do the solving? So in this case, I have my U1, U2, U3 expressed as A0, A1, A2 times what? Times this 1, 0, 0. And then second row is 1, 8, 0. And then last one is 1, 0, B. Okay? So do you know this expression? This is basically the coordinate of the nodes. 1, x, 1. 1, x1, y1. 1, x2, y2. 1, x3, y3. So in that way, would you be able to find your A0? Because the unknown is A0, A1, and A2. So by using your Cramer's rule, A0 is 1, 0, 0, 0, 1, A0, and then 1, 0, B. And then this one, the first row is replaced by U1, U2, U3, 0, 0, A, 0, 0, B. Okay, what's your A1? Your A1 is U1 times AB divided by 1 times AB. 大家看得懂吗？怎么算的？这个就是你的行列式怎么算？行列式的，就你行列式的，你拿一行一列都 OK 啊。然后乘上，比如说我这里要乘上斜对角，再加上这个负的，乘上斜对边，再加上正的，乘上斜对角，对不对？这个行业是什么时候学的？大学啊？我说 OK， 这个行业是复习一下。So now you got your A0 is U1. And then next, what do we do next? We find my A1. What's my A1? My A1 is the second variable. I have the second column replaced by U1, U2, U3. Okay, and then last one is 0, 0, B. Okay, in this case, for my convenience, I'm going to use this term. Okay, this term is my B times U2 minus U1. Okay, and then that will give you U2 minus U1 divided by A. Okay, and then I continue for the A3. A2 will have the last row replaced by U1, U2, and then B. This is by 1, 1, 1, 0A0。所以你要怎么方便算呢？那我找一个微非零项，正负正，它的 cofactor 是什么？What is the cofactor? To calculate the one, this is B. Sorry, this is the U3. U3 times 1 minus U1. And then this one, A2 is equal to U3 minus U1 divided by B. 所以看呢，我们把这个方法用到一个例子，这个例子比较简单 ，OK， 比较好写。However, if you are not sure, okay, for any arbitrary triangle, you might not have that simple expression. Instead, you're going to have U1 times the cofactor minus U2 times the second cofactor plus U3 times the third cofactor. 这个 cofactor 怎么找呢？就是你站在的位置的这个，除了你这一行跟这一边，其他现在就是你的 cofactor。是吧？就是扣掉你那一行跟那一边，其他的就叫 cofactor。所以你行列式的这个算法基本上就是 U1 乘上你的 cofactor， 再减掉 U2 乘上你的 cofactor， 除掉你那一行，除掉你那一边，再加上 U3 乘掉它的 cofactor， 除掉它那一行，除掉那一边，那就是 cofactor。cofactor 中文的。Okay, after you have this, now you also have determined one important information in the denominator. In your denominator, this is 2 times the triangle area. Okay? So the expression of that is complicated, but if you remember this, okay, then you realize that oh, the meaning is there. Okay? So you can give it a try. So is this the area? 所以我们就用你的这个直角三角形来算啊。这个面积好找啊，就等于 a 乘 b 除2，对不对？没问题啊。然后我们是不是把这个带进来？我的 cofactor， 我的这个 determinant。这个是2倍型的面积吗 ？OK， 所以最简单的地方我们就拿这个这一行1乘上 AB， 这不就是我三角形的2倍吗 ？OK， 所以这个就是三角形的2倍面积。Okay, in that way, you use this determinant to find out the area twice the triangle. Okay? Okay, let's continue your A1, determinant of A1, A2, and eventually you can express A1, A0, A1, A2 is equal to the inverse of this matrix times U1, U2, U3. What is inverse? If you are not sure, then we can use the method. Yeah, so later you can decide, are you going to have final examination on PC together with Finite, okay? Because we can use your symbolic calculation, but there is a risk. If you are not familiar with procedure, then you cannot finish the project. 所以之后你们再考虑一下，你们考试到时候要用上机用算这个符号解呢，还是要乖乖用手写 ？OK， 好，我们大概给大家看一下。Let's try. How do you find the symbolic calculation? Let's try first. Okay. Yeah, correct. Okay. So you do now have these matrix. Okay. One x1, y1, one x2, y2, one x3, y3. Okay. So this is your matrix. If you want to find the determinant. So this is your determinant. Okay. And then next, let's see what you want to find. You want to find your expression in terms of u1, u2. Let's define the simple u1, u2, u3. And then now if you have the inverse of the matrix times the vector can be expressed as a semicolon. Yeah, so it's going to be a very complicated expression. Let's simplify the expression. Yeah, it's still complicated. Okay. So yeah, I think if you multiply with the area, okay, if you multiply with the area, the expression can be simplified. Okay. 所以大概就简化出这个例子来。Okay, so it's too tiny the wording. Let me change the size. Change the size. Okay, then I check on my display setup. If I check on my display setup, the display setting. So you can see that this can be done by your method expressions. But here the important thing is, you see your A1, your A0 depending on U1, U2, U3. Okay? And then your A1 depending on U1, U2, U1, U3, U2, U3. And then your A2 depending on U2, U1, U1, U3. All are displacement function. Okay? We come back our presentation. If you do the inverse, the important thing you find that the coefficient for linear function A0, A1, A2 is depending on, is actually depending on the northern coordinate as well as displacement at the 3 nodes. Okay, you can separate them so that you have the U1 and their coefficient, U2 and the coefficient, U3 and the coefficient. Okay, likewise for A1. And now, if you do the substitution in, okay, what do I mean substitution in? I substitute A0, A1 and A2 into my expression there. Okay? Then I'm going to have this 3 terms. Okay? The first term is a constant. Okay? So it's independent of x. Okay? And then the second term is proportional to x. And the third term is proportional to the y. Okay? But here, my interest is not to express them as a function of x and y. Okay? My interest is to express them in terms of U1, U2 and U3。看到没有？我们现在要带进来的是形状函数的概念。我并不期许我知道我位移的在空间场上的绝对变化，我只关乎 ，OK， 它在这个三角形里面 ，OK， 如果说节点位移已经给你了 ，OK， 像这个节点位移在其他位置的影响是多少？因为它是这个节点位移是在空间场上是一个线性的分布，有一个梯度 ，OK， 所以这个线性梯度可以用空间场上的形状函数，这个形状函数就是乘上 U1 的这个系数，这个系数不是一个定值，它在空间场上它会随 x 变化。所以看到没有 ？What is the coefficient that define the shape function? It is the first coefficient times 1, second coefficient times x, the third coefficient times y. So this gives you the definition of the first shape functions, okay, and 1. Likewise, you have coefficient times 1, coefficient times x, coefficient times y. This gives you the definition of the shape function 2. And then the third shape function will then be coefficient times 1, coefficient times x, coefficient times y. So eventually you come out 3 partially variable shape function. And when you do the expansion, okay, then you have these 1 over 2a times the expression of x and y plus 1. Now as n2 also, the coefficient times the second one times x, third one times y. Likewise for the third shape function. Okay. The shape function is partially changing. Assume the same interpolation also applies to vertical displacement. We're going to repeat it, and the shape function remains the same. So, because the shape function is the same in the x and y direction, so yeah, people say that this is also so-called the isoparametric formulation of finite element. Okay, the first finite element invented is actually is based on the use of this shape function. So you can see now there are 3 shape functions for triangular element. 1, shape function 2, and shape function 3. And next important thing that you should realize that because the shape function is 1 at local node, 0 at opposite nodes. If you now have shape function 1, 2, and 3 added up together, what will it be? 来，同学猜一下，形状函数刚才已经画给大家看了，它在地节点是1，对面两个节点是0。那形状函数1，形状函数2，形状函数3加起来是等于，加起来等于1。OK， 这里是3个斜坡。OK， 那合起来就变成一个平台。So that's why, in a way, people also try to simplify the expression. Rather than using 3 shape function, people can say, I use 2 shape function. The third shape function will be 1 minus the second, 1 minus the first and the second shape function. This will then be the third shape function. 所以形状函数还有另外一个意义，除了刚才的梯度的这个意义，你还可以把它三角形跟你在地那个点3等分成小的三角形，所以你的形状函数1是对面的小三角形除以整个大三角形，所以你在这个 P 点上的形状函数，这个点去把大三角形3等分，形状函数1就是它对面的小三角形 A1除以大三角形，形状函数2呢是对面的小三角形 A2除以整个大三角形，形状函数 A3就是你的对面的小三角形除以大三角形。So there is another definition of the shape function that is based on the area ratio of local point. If you now stand at the point P, then you can divide the triangle into the 3 sub-triangles, A1, A2, A3. Then the shape function N1 will then be defined as the opposite sub-triangle over the total triangle. And then N2 will be the opposite sub-triangle A2 divided by the total triangle area. And then N3 is defined as the opposite sub-triangle A3 divided by the total triangle. Of course, the other way of defining shape function is what we have learned about. It is the grading of the height. Okay? And because you see that the variation of the displacement is linear. If you take differentiation of the displacement with respect to the coordinate, then it will be a constant strain. Constant strain in the x direction and constant strain in the y direction. So this is a stepwise approximation for the strain. So in a way, we also name this constant strain triangle element. Okay? 所以我们现在用有限元去分析是非常粗糙的，它基本上就是把一个空间变化的应变去割成很多梯点。OK， 你们看过在山坡上梯点，就是一阶一阶的。OK， 反正你围起来的灌的水就是一个平面，一个高度的。再下一块地，然后把它围起来，是再灌盖的水，又是一个高度，一个水位高度。所以你们的这个应变的变化，它没有一个连续的变化，在空间场上没有，它这个应变被 割成很多道梯。So this is what they call constant strain mechanism. For the for the partially bearing strain is now being converted into stepwise constant strain. So now what we're going to do, we're going to relate displacement to the force. We have spent a lot of effort interpolating the displacement in the x and y directions. And we also obtain the constant strain. Okay? So now, how are we going to relate it to the nodal force? Okay, to relate it to nodal force, we start applying this strain component and their relationship to displacement. Okay, 所以看到没有？刚才我的这个应变跟位场的关联性，就在于你形状函数的这个变量。所以你形状函数这个的斜率怎么排，就取决于你的节点的位移怎么排。前段时间我们节点的位移的排法可以是 U1 V1 U2 V2 U3 V3， 但是我现在排法是 U1 U2 U3， 所以你对应的形状函数的这个斜率就变成 N1 del N1 del X del N2 del X del N2 del X， 而不是被这里所分割。So now you define what you call a strain vector is displacement gradient, a shape function gradient times the displacement vector. Of course, the other expression here is just tell you the contrast. You are doing the same thing, except the sequence and order of the displacement vector are expressed differently. So also, strain is related to displacement by means of the V matrix. V matrix is the matrix of the shape function gradient. And now, your V matrix. Okay, upon substitution of my shape function gradient, okay, 你的这个形状函数的这个斜率怎么找呢？我们看一看。Let's see the shape function. So remember the shape function? If you want to find the shape function 1's gradient with respect to x, this is the y2 minus y3 divided by 2a. Del n1 del x is this coefficient. Del n1 del y is then x3 minus x2. So this shape function is there, you can obtain. Okay? And then finally, yeah, you come back to the expressions. You have this shape function, and then you have the V matrix being the gradient of the shape function. Okay? So if you group them that way, del U1 del X will have a coefficient solely depending on Y. Okay? Del U, del V, del Y will have a coefficient solely depending on X. Okay, these are the difference. And then del U, del Y plus del V, del X will then have a coefficient of this. Okay? So yeah, for this part you really need to go back and derive it one time. Okay? So this difference, y2 minus y3 can be expressed as y23. y3 minus y1 can be expressed as y31. y1 minus y2 can be expressed as y1. This is a shorthand. Okay? And then this formula can be used provided you follow the sequence being called and being counted for 所以这个公式用的对不对，要依你节点的顺序。你节点一定是要逆时针的顺序，1、2、3，这个公式可以用；3、1、2，这公式也可以用；2、3、1，这公式也可以用。但是你1、3、2，你公式刚好错位，所以你算出来的就是错。OK， 所以当你用 ANSYS 的时候，因为是编程，那个顺序它已经帮你算好了，不会有错。但是你如果用手算的话，同学常常解题的时候会算错。明明老师给我这个公式啊，我节点顺序是1、3、2啊，为什么另外一个同学节点顺序是1、2、3就对，我1、3、2就错？那没办法，就是推出来就是它的那个顺序有关。OK， 所以你们一定要记得，你是逆时针的顺序，1、2、3。Okay. So this is important because if you don't follow that, the expression of the equation will be different. Okay, you have a difference in the negative sign. So eventually, your B matrix is valid for this normal sequence, counterclockwise sequence. Okay. So if you doing the opposite, what happens? Okay, if you're doing the opposite, okay, this term will have negative sign, and then this term will have negative sign. The other negative sign appear here. So it's not negative for all coefficients, but it's negative for certain coefficients. So this will make your calculation quite difficult if you don't stick to one. Okay, so that's why we suggest you please use the convention of counterclockwise normal sequence. Okay? So now we can start apply to the example. We now have example of a rectangular plane stress elements. Element 1 and element 2, they form a rectangular, they cover the rectangular area. Will you be able to find how much, what is the stress order displacement matrix B? Okay. First, you decide the area. Okay, by hand calculations, right angle triangle is easy to calculate. Okay, then you have 1 over 2A. And then the B matrix is simply substitution of this value. But when you do this substitution, please write it 1 time, so that upon substituting the value, you get the right sequence. 所以同学解题的时候，有时候要抄一次那个公式，然后再把值带进去。OK， 你们考试的时候啊，有时候很多同学都不写公式了，直接给老师答案，那老师就没办法，你答对就满分，答不对，给老师没给你0分哦，给你60分、70分，这样你就亏了嘛。OK， 如果完全看不懂的话，就变成60分，看懂一点可能70多分。OK， 所以你要帮忙改卷的人来显示一下你懂不懂啊，所以你要几步要多写一下。Okay, next, can you please do the same for the other triangle? Triangular element. Okay. So now, how much the stress in this triangular element? Okay, if you are going to find out the stress, okay, then you can express this expression. The stress value will be this constitutive equation times the strength, and then strength is the B matrix times Q. So the stress value will then be E over 1B squared times this matrix times 1 over 2A times the B matrix times the displacement vector. Okay? 所以同学在应用上次解简单有两单元的时候，绘不出这个 stress， 这个 stress 画不出来的原因是 N 是这个内置的这个 stress 是根据平面元素或立体元素来定义，杆跟梁它不是平面或者是立体元素，它不存在所谓的 dynamic stress。所以你一般要算平面的 stress， 还有 volumetric stress， 是从这些算出来过后再处理。So now this gives you the stress displacement relation. And of course, after you have the stress in the x component and stress in the y direction, of course you can apply your principal stress method. Okay, and then you can find out the principal stress to be the sum of the stress in the x and y direction divided by 2 plus the square root of this sum square plus the shear stress. Okay. 所以你呢用墨圆的方式可以找到这个主轴应力在 x 第一个主轴跟第二个主轴，然后主轴的角度可以通过墨圆的方式去找出来。Okay, so this is a part that if you want you can revise it. And next, then we are trying to find out the force vector. As we tell you before, okay, we can derive the force by differentiating the energy, in particularly the strain energy, with respect to the displacement. We have derived it before. This is normal force is going to B matrix transpose and B matrix times B matrix times T times A times the displacement vector. So now recall your shape function. Do the differentiation with respect to x and with respect to y, and then substitute in to the B matrix, and then if you do the matrix product B transpose and B matrix and B transpose B. What is the size of the B matrix? Is 1, 2, 3. 3 by is yes 6. 3 by 6. And this one is 3 by 3. This one is 6 by 3. Okay? 所以你的进度矩阵现在是大小多少？6乘3，3乘3，3乘6。所以你的进度矩阵现在大小是6乘6。OK， 所以一般来说要考试的话这个就有点难考，我只能考你一个三角形元素。OK， 你可能已经会叫苦连天。OK。所以上次第一次期中考三个变量已经难倒不少同学，所以后面就看你们可能会给你一个 Method session， 看你们 Method 练得好不好。OK， 如果练得好，就用 Method 来解；练不好就还是继续手写。OK， 可是题目考试能出的题目很有限，只可能出一个三角形元素给你。那手写的会是对的。但是用那样的也有做不对的。不要那是说
手写超容易失误。
对。
超容易计算错误。
Okay, we'll see. So let's practice first and then we'll see how you progress. Okay? So here the important part for the tutorial, for the homework, you still need to solve by hand. Okay? So for the first triangle. Okay? Because without solving by hand, you cannot master this subject. Okay? You can't dump everything to software. Okay? You need to practice on. Okay, usually the question could be quite limited. Okay? So also you see, this product, how can I handle that? If you handle by hand, high chance you get it wrong. That's why I use MATLAB. But even when you handle by MATLAB, this thing is very complicated. Okay? Unless you have a simple right angle triangle shape. Okay? Anyway, even though the expression is difficult, but fortunately, people have derived that, or you can do step-by-step calculations. Okay? So it might be very difficult to take the whole product, but you can handle B transpose B times B. OK， 所以一般如果你要手解的话，你一般就没本事去把它展开来。一般的做法就是你找到 B matrix， 然后后面就数字解还是什么方法，你再乘 B matrix， 再乘上 B matrix。OK， 当然早期的书也有完整的把这个 matrix 写下来，让我们看一下。So next, we also have to consider the force acting on the triangular element. Besides normal force, there are also going to be distributed force. Normal force is easy because as you differentiate the total potential energy, then you can simply say, oh, this is just normal force. Okay? But for distributed force, okay, then you've got to differentiate differentiate the shape function. 好，我们来看一下你的那个分布力怎么算。Okay, let's come back to our this right angle triangle. Yeah, it's easy enough, isn't it? Your shape function is your n1 is your 1 minus x over a minus y over b. Okay, your n2 is your what's that? X over a. Your n3 is your y over b. Okay? Okay. So what happens? What's the force acting along the line?好，这个斜边上的那个分布力是什么？你说有一个分布力是 Px Py。So this is a component of your force. Okay? But now this force is distributed. Okay? So the work done by this force, is Px times u plus Py times b, and then integrate along the length. Okay, this unit of the force is Px, Py as the unit of Newton divided by length. Okay, this is the distributed force. So if now you want to do the differentiation of the work done with respect to u1, then your expression here is Px n1 plus Py n1 一样的。So the good thing about this shape function is, if you have uniform stress on the side opposite to not 1, they will equally divide the force. 所以这里总力是多少？它基本上 Tx 乘上全场 ，Ty 乘上全场，然后把力，结果分到了两边，这是 Tx L 除以2，这是 Tx L 除以2，然后这里呢是 Ty L 除以2，这是 Ty L。So this interpolation, even though we do it by partial differentiation of the external work done, they will do the same of equal dividing a uniform tension onto the two knots. However, if the distributed force is non-uniform, it's not equally distributed. If the force is a little bit graded, then you have no choice but doing the proper integration. And this integration has to be done along the length. 所以同学，如果你对线的积分不熟，你要回去试试看怎么积分。一般大家都没问题啊，我积分 x 走，积分 y 走，但是现在积分斜线可以吗？所以你要去转换一下你的坐标 ，OK， 沿着斜线去做积分 ，OK。So in that way, so we have the normal force due to the fraction. This is obtained by partial differentiation of the work done by fraction force with respect to the normal displacement. So just now, you got differentiation. If you differentiate the work done by U1, then you have force M1 x. If you differentiate the work done by U2, then that will be the force F2 x. Okay? Can I differentiate U3? Because U3 has nothing to do with this opposite end. So then there will be no force contributed from the traction force on the U3. Okay? So that is also a good thing about the shape function, they will take care of that. 所以你看到没有？你的这个分布力 Tx Ty， 你可以把它想象成纯 Tx 加纯 Ty， 然后运用形状函数，然后这个方法，你可以把你的分布力分到节点上。Okay? So likewise, you can do the same for the traction force along the y direction. Okay. So here there is an example to illustrate you the combination if the distributed force is non-uniform. For uniform stress on the bottom line, not 1 to not 2, is basically that force intensity times the length divided by 2. Okay, but if it's non-uniform, then you got to apply your shape function. Okay, so just now we have already obtained you the shape function. Okay, so if now the shape function is non-uniform, yeah, then 好，这样一题这个力是不平均分布的，但是线性分布，同学要怎么算？ Okay, so we tell you before you x, y is n1, u1, n2, u2, n3, force distribution on line 2, 3 can also be expressed as N2 D2 plus N3 D3. Okay? In this case, D2 not equal to D3. Okay? Okay, so if that's the case, your work done, okay? Your work done got to be applied properly. Okay, what's the work done? If you're going to calculate the work done, then you're going to derive it from the basic formulation.我们先讲的这个做的功，就是你的力，这个力。Okay, so this is the definition of the work done by distributed form. Okay, in this case, what? Oh, okay. Yeah. So this is only the horizontal force. Okay. Okay. So this one is 0. Okay. But your Tx can be expressed as Tx1 and N1 plus Tx2 and N2. And how about the displacement? The displacement is U1 N1 plus U2 N2. And then the L from 2 to 3. Okay, if you now want to find out the force, F1x, then you have to differentiate W with respect to U1. Okay? So the only term there is dx1 n1 plus dx2 n2 times n1 dl 2 to 3. Okay? So what is the shape function? 好，我们来看一下我们的形状函数。这个三角形的形状函数，这个怎么找 ？OK， 这个是这个形状函数，因为我们是现在看到就是1、2、3 ，OK， 是不是？你现在是在2、3啊？这个写错了。这是2、3，这地方must be expressed differently. Because you are on the not 2, 3, so you can only be on 2, 3. There won't be F1x, there will be only F2x. The contribution on not 2, 3, the traction contribution on not 2, 3 will not contribute to any force on the not 1. Okay? So now what are the shape functions on not 2? On not 2, what are the coordinates? It is 1, 0. Okay, the opposite shape function must be this diagonal line, is it? So this is the, is it? Let's see. 好，那我们看一下这个形状函数。 how to find the shape function? Of course, if you do with the Method, this is the standard way of finding the shape function. Okay? But if you're doing by your brain power, then your linear algebra is helping you to find the shape function. Okay? So shape function from not 1, okay, 0, 0, have opposite side, okay, being 0. Okay, this opposite side is 1 minus x, okay, so it's 0. But then not 0, 0, this n1 is going to be 1 minus 0. Okay? And then next, we see the shape function for not 2. The opposite side is 2x minus y. It is 1 upon substituting not 1, 0. Okay, this is. Sorry, I think this should be the x minus 2y. So it's 1 minus 2x. Okay. So it's 1. Opposite side is along the line from 0, 0 to 1, 2. Okay, this line is 0. And then how about the shape function from not 3? The opposite side is at y equal to 0. Okay? So to make sure n3 is 1, this should be y over 2 at not 3. Okay? And at 0 point is 0. Okay? Now, once you have the shape function, you can substitute in the definition. And not 2, what are the force contributed by the traction? Traction is distributed load. It is the N2 times Py and integrate along the length. This N2, according to our previous calculation, your N2 is x minus 2y. Okay? So if you bring in here and then multiply the traction force and times the thickness and then integrate along the height, then you're going to find it to be 10 pounds. This is according to the textbook. And likewise, you can do the integration to find out the force, okay, on not 2 along the x direction and y direction. And finally, yeah. So after this, so we come to the last example. Yeah, this is an example that to validate your finite element method. Okay? So remember, finite elements are just approximation. You have to check it against analytical formula. If now we have a rod being rectangular and we have a plate being rectangular, it is subjected to uniform forces. How much is your extension? Okay, you should have an analytical formula. So let's see what will turn out. In this case, you know there are going to be force balance. External force is going to cause internal force, which expressed as a stiffness matrix and displacement vector. Okay, what are the external force? On knot 1 and 2, there are reactions, which are known. On knot 4 and 3, this is the external distribution force. Okay? You can go and calculate, this will be fine. Okay? Now we have the force determined. And then next, this force is, you've got 4 reaction force. On knot 1 and 2, you have the traction force times the height divided by 2. So because this is only Tx, So we uniform, then we divide it to be half on not 3x and not 4x. Okay? Then the right hand side is a stiffness matrix times displacement vector. In this case, you have u1, v1 being 0, u2, v2 being 0. You are left with 4 unknown. Okay, this is now you challenge your algebra already. And then now you have two equal right angle triangle. And then the triangle area is half the height times the length. And then next, you go and determine the B matrix. Okay? The B matrix can be obtained in this formulation. And then next, you're going to obtain your stiffness matrix, your stress. Okay? So rather than doing one in the step, we do step by step. Okay? First, you find B transpose times D. So B matrix transpose times the consecutive equations, end up you have an expression there. And then next, you find your stiffness matrix. It's not complete yet because supposedly your K here, so multiply with your T and area. Okay. You multiply these. We haven't done the stiffness matrix yet. Okay? So only when you do that substitution in, then you have a complex expression. And then this is done by solving using Method. Okay? So your Method will give you very complex expressions, but you may not pay that much, so long as you find out the one related to your free node. Your free node are U3x, U3y, U4x, U4y. So you single out those related, and then eventually also you notice that then you single them out. Your U3x, U3y is related to your F3x, F3y is related to the U3, U3. Okay? And then next, this one is a 3, 4. Okay, this is a matrix that you retrieve and eventually group them together. By grouping them together, then you can start doing the solution. Okay? So the solutions will then be obtained. Okay? 就是看到没有？我们开始在写这种题目的时候，这个就已经不大能用手写了。OK， 这个虽然只是一块板，一块薄膜，末端拉长，这样你可以推导你的力。OK， 但是你这个式子已经开始变得很复杂，一般所以最终变成数字解，然后用数字来说话。但是你数字解出来有一个很重点是什么？请问这个第3点、第4点的垂直物力是多少？你一块板用水平力，第4个点的垂直物力是多少？就是简单来说应该是0， 但是这个板的话，如果有波松比，你拉长的话，它会缩短，所以它高度方向，这个第四点会向上，第3点会向下。OK， 所以是根据你对波松比的效果，你知道的答案。OK。
是我们从 N4就直接设计在里面，所以就可以把这个概念到。
所以我就告诉你们 ，N6 你用的时候要小心谨慎，它不会告诉你正确答案，你要先去比对正确的前或后，你才能确认 N6 对得上对不上。所以卖 N6 给你的人，他就告诉你啊，我会算给你对的，但实际上你去看波音的工作经验，你知道波音为什么一直掉飞机吗？50年前到现在，它的材料数据是50年做的，50年前做的，它以后就没有再做彻底的材料。它的有些年模型，它那时候是用 NASA， 也是50年前做的，所以它是50年前的数据跟 N6 做比较，或跟Finite做比较，那个是矫正过的。OK， 但是这50年下来，这个坐飞机不比印钞票赚钱啊，卖股票好过坐飞机啊，所以这个波音才搞出波音737 MAX， 那是50年前的飞机设计，50年前的 simulation， 而且美国人很喜欢搞 simulation， 那 simulation 说白一点就是 rubbish in rubbish out 啊，所以你有没有看到老师给你们播的影片，都是 Airbus 给你做实验给你看。美国这50年印钞票太爽了，OK， 所以他换了引擎很有力啊，那个机身没换，所以才会搞到这个引擎很有力，那个飞机爆冲会抬头，所以他就加了这个 artificial intelligence，飞机可能会抬头，我就把它压下去，所以那个几起空难都是这个电脑要把飞机抬上来，然后飞机师要把飞机压下去啊，所以到后来就是才会有这个意外。所以有些元素你看到这里这么粗糙的元素，你拿它来用，那个是搏命 ，OK， 这个对还是不对，有很多假设，并没有被考虑在这里。OK， 我现在仅只是一个元素，你当然说你计算量一增加，你的精度会提高，但是没有涵盖在这个计算里面的是，我们现在分析只是外力、平面力，你还没有考虑的是内应力。我这个飞机不再是用铝来做的，铝你可以说我切完那个形状就有了，就没有内应力。但是你现在飞机做是用复合材料做的，你是用碳纤板去烤完有内应力，内应力怎么算？不好意思，算不出来，你要测。所以这些计算只是给你一个框架 ，OK？ 所以你如果说有一家公司告诉你，我可以帮你算，然后给你一个好的设计，你可以节省成本，你十之八九不能用这家公司的这个产品，因为实验有很多因素，不是模拟能计算得到的，所以模拟只能告诉你趋势 ，OK？ So, take for example, when I do my PhD, I start doing design simulation to make the small chip on silicon. Okay, by the end of my experiment, it is 1 order higher or lesser than my calculation. Okay, provided I provide in the right material properties and research, I will not get the right answer. 所以很多那个模拟的公司，他在竞标这些，比如说 NASA 项目之前，如果 NASA 不做实验，所有模拟的公司，这个答案可高可低，趋势都有 ，OK， 趋势相近， 但是等实验一做完，大家的这个模拟的数据都收有，所以你就知道这个模拟这个东西，差不多看看就好，一看趋势，就是说最终你还是要实验来定。So this part is a little complicated. So I can go through with you the working. Okay. Using MATLAB. So let's see the.
Is all the calculation, so it should be no problem, right? If we
That calculation is just, as you can see, is neglecting a lot of effects. So I only purely consider external force, no restraint. So that will work for method. 有些人就只是适用于金属材质做小型变 ，OK， 包括金属材质做大型变，那就不行，因为有内力。对于塑料而言，老师现在都用塑料做自动剂，基本上是不用有些，因为我要测完才知道塑料性。这个学生如果勤快的话，这个做实验比用 NC 来的快 ，OK。所以一般来讲，塑料就用有些的情况比较少。当然，就是说，除非说形状几何非常复杂 ，OK。就不方便制作，所以还会有人去用这些。Okay, so let's work out the working step. So let's see if I have the MATLAB script. Okay, how do you do the calculation of the shape function? So let's see, rectangular element derivation. Okay. So, we see this one later. Okay, so this is an example that we apply. So you can look at this problem solved. How do you solve the problem using MATLAB for concentric triangle? Okay. So the first thing you do is you define modulus, you define Poisson ratio, you define the length, you define the height, define the coordinate. Okay, here the coordination must be there. I define it to be I, J, K. It should be counterclockwise. Okay? So all the formula you use, if it's counterclockwise, you use one set of formula. If not, then you use another. So you see, my first knot is 0, 0. My second knot is L0. My third knot is LH. Okay? And then I have my XY matrix being XI, YI, XJ, YJ, XK, YK. I don't use X1, 2, 3 anymore because I later might have the second element, which is not 1, 2, 3. It might be 1, 3, 1, 3, 4. Okay? And next, your matrix, I will again call my matrix script. Upon substituting the matrix script, you will have your D matrix, which is the constitutive equation. And then within this, then you have to call this function. This function will also calculate area for you. Okay? Okay, what is your area? Area is half the determinant of 1x1, y1, 1x2, yj, 1xk, yk. Okay? And then next, this is then giving you the area. And then the B matrix will be using these difference. First is the yjk, yki, and then yij, and then next is the kj, xkj, xik, how to calculate the stiffness? We calculate the stiffness by doing the matrix product. This is B matrix transpose and B matrix and B matrix times the thickness and the area. Okay? And then finally, then you have the expression. And then now you have the complete. For element 2, you are doing the same. But now the sequence of the knot is 1, 3, 4. Okay? So then you obtain stiffness matrix in that way. Okay? Upon substitution of the value. Okay? And then you have to extract the 3 knots. The 3 knot is 2, 3. Okay? And then for the element 2, there is only one 3 knot that is 3. So you just single that out. Okay? And eventually, then you're going to have them combined. Okay? Element combined, then you can start the calculation. 好，这个部分就开始有点复杂了，所以我会把这个额外的这个 PPT 上传给大家，然后大家到时候可以做简单的三角形这个元素的这个解题。Okay, so with this I'm done for today.